we're streaming. Just double checking that it's working. Seems to be. All right. So last time I was unboxing this humanoid from Hiwonder. Pretty awesome. Full humanoid. And has many joints. And I'm just trying to build my expertise in humanoids. The surprising thing is that this costs €900 when usually these kind of robots can cost 10,000, 30,000, 100,000. And it has a lot of the same functionality that other humanoids have. Obviously, it looks a bit like a toy, but it has 24 degrees of freedom. And I'll go through that. But I covered the unboxing last time, and I've created this public Notion page to describe what I'm doing now with it. So I kind of had this last Twitch stream to unbox him, and since then I've had 162 commits in my private repo, just doing everything I can to make him do interesting things. I want him to pick up socks and play football better and pick up other objects and follow me and come to Papa. Many different things I can show you that I've been working on. It's a pretty advanced machinery and a lot of complicated things that go into making humanoids work. I have a log of what I'm doing every day. Yesterday was some fixing the mismatch between what was being shown in visualization versus the real world. And then I was doing some simulation. But today, my plan is to talk a bit about Humanoid Hype, Humanoids 2024 conference that I went to. And I can show Johnny and all the servos again. So he's got a lot of different servos, a lot of different motors in his body. But before we get there, so let's go to Humanoid Hype again. So it's just kind of crazy how much hype there is. Not a very good image. But on the left we have Electric, Atlas, 1X Eve. The other Twitch streams have this 1X humanoid showing. Unitree has a H1 but also G1 now. Figure is already on version number 2. Phoenix, haven't seen much from them, but they've been going since 2015 or earlier. Apollo, Optimus, everyone's seen Tesla. They have a good chance to do well, and Digit, they literally have Agility Robotics has a factory to mass produce this. And I went to Humanoids 2024 there. It was a really good conference. I went to Nancy in France. It was a lot of fun. There they talked about over hundreds of Chinese companies are building humanoids. Now we might go through a hype cycle and a trough of disillusionment. We might go up and down and have a robotic winter, but also I think the technology is almost there for it to work really well. So I think it's going to be a crazy 10, 20 years, and it's not a question of if humanoids will come into your home and cook dinner for you, it's just when. So yeah, humanoids are pretty hyped at the moment. That's why I wanted to buy this little guy beside me. We can do lots of things. It's obviously small and a bit toy-like, but it's all ROS-based. I bought it from this Hiwonder company. Pretty good price. Got the Raspberry Pi 5, 8 gigs RAM. Do lots of things straight out of the box, and that's what I'd like to show you today. Color recognition, auto shooting, football, inverse kinematics, built-in IMU. Hopefully I have time to show that. And there's many different servo joints. 2 in the head, 2 times 2 in the shoulder, and then 2 shoulders. That's pretty advanced, and all the code is controllable and changeable, so that's why I've had 162 commits here. Cool. So, let's see. Humanoids are hyped. I think I've covered that enough. And I want to kind of ride that hype train because it's fun, because it's also like iRobot, the future of science fiction. We'll need Will Smith to save us. Soon. Be scared. There's a lot of also fear, and Terminator is like the personification of AI, and that we're all going to die. But it also could lead to a deep utopia of where labor is free, as the 1X CEO talks about. Is Elon Musk right, and we'll have 10 million humanoids by 2030? Probably he's, as usual, too optimistic. But eventually, even if it's 5 years wrong, what if we have 10 million humanoids by 2035? I mean, I have a humanoid now. Just this little guy I can hold in one arm. So let's go through his 24 degrees of freedom. So 2 in the head. So head pan, so like a yaw ankle, and head pitch up and down. Pretty useful. That's mostly what you need to do face tracking in 3 dimensions. We have on one arm here, we have shoulder roll and shoulder pitch. Only 2 degrees there. In the elbow, we have probably elbow pitch and elbow roll. In the gripper, we have able to close. I cover them all. So 1, 2, 3, 4, 5. 5 degrees of freedom per arm, which enables you to obviously get low and like. Let's see if we can pick this cube that it came with, and yeah, it's pretty good. This is him off, of course, but 5 degrees of freedom per arm, 2 in the head. Then the legs are a bit more complicated, but we've got starting from the bottom is easier. We've got ankle roll, it's useful, so you can keep the flat of the foot on the ground while reaching out, like in a side split kind of thing. We've got ankle pitch, of course. That's useful for squatting and for humans too, biological humans. You can do squats. So we got ankle roll, ankle pitch. We got a knee for kicking. That's useful, and for squatting. I'm always trying to find analogies between real humans and robots, because they are built in our image. A lot of debate about whether that is a good image to copy. Like, why it's not the ultimate. Robots don't need to have 2 legs. Why not have 4 legs? Why not have 10 arms? But on some level, the world was built for humanoids. So why, for humans, biological humans? So why not at least try to do some biomimicry and learn? It's always a scientific challenge, but now there's all this business behind humanoids and a lot of hype. I have conviction and I'm committed that I think it's gonna work. And that's why I bought this guy for €900. Anyway, as I said, ankle roll, ankle pitch, knee. Then we have hip yaw. Like, you can rotate like that. And we have also hip pitch, bringing your femur forward. Did I cover everything? I'll go back to this page. 2 in the ankle, 1 in the knee, 3 in the hip. So I did hip pitch, hip yaw. What am I missing? Oh, pitch, yaw. Also roll, hip roll. That's super cool. That's how you get a middle splits. Okay, so it's like, yeah, 3 degree of freedom hip. I covered the gripper in the hand, 2 rolls, 2 in the elbow. That's different than a human. Human only has 1 degree of freedom in the elbow, but when we roll, we're actually rolling the shoulder. So it's a bit strange. Usually the shoulder should have 3 degrees of freedom and elbow 1, but one of the rolls went from the shoulder to the elbow. It's a bit debatable if it's roll or pitch. And 2 in the head. Cool, so I've covered all of that. I think we should turn him on. Let's see. Put him into a squat position. I'll read the manual again. I've been wondering actually if he needs to start in a squat for him to stand up. So, and lights are on. Takes about a minute to start. I generally don't need the manual, but there is instructions on the different modes. Standard mode, green, and then there's ball shooting mode and line following mode. Don't have any lines, but I haven't actually done the line following yet. Yeah. Okay, he's kind of stuck. Or even try to turn the controller on to see if he stands up. He's fallen down a few times. Sometimes a screw gets loose, but I got him. Cool. So he's standing, and I have his controller, and he can walk forwards. He can walk backwards. Careful. He can walk sideways. Strafe in video games. And you can also even walk diagonally, so like if X direction and the Y direction. At an angle, 45 degrees. Northwest, north, south, southeast. Cool. Gotta be careful here. Space. You can squat and actually walk low. And increase his height. Walk high. And at his back you can actually see voltage that says 12 volts. When it gets below 10, that's when you should turn them off. So I get about an hour or 2 hours of play with him. And he can also rotate on the spot. Rotate his yaw angle if Z is pointing upward. The Z axis. Usually the Z axis should point upward. So given that, he can actually do lots of things. Then I actually changed this default code a bit, the controller, so you can do a few different moves. So I made the A and the A, X, B, and Y buttons do different things. So A, I'll give it a bit away, you can see that too well. X is a big step, hurdles. That's to step over big hurdles. Oh yeah, and I've called him Johnny for no reason, just like the name. It's pretty impressive the balance that he's able to have, even without torque control. It's all just keyframes and inverse kinematics. Pretty good balance. So that was hurdle, long walk. B, you do a little wave dance. Y, that's the kick, the right foot kick. I put the ball in front here. The ball keeps moving. I'll do it fast enough. No. This table is at an angle. The cube to block the ball. So yeah, he can kick. Cool. Then I made a L1 R1 move the head very slowly. See there? That was useful for slam. I'm trying to... Sometimes the head is shaking a lot while he's walking, which makes slam harder. I was trying to orb slam 3. So if the camera can move much slower, that's nicer for slam, I thought. But still, slam is hard. Hopefully another Twitch stream on that later. L2 and R2 is the pitch angle. Looking up. That's kind of creepy. He's looking at the camera. He sees you. And he says hi. They kind of look good. Cool. So that's remote control. I can't really show football on this table because this ball keeps falling off the table. I could put him on the ground, show you the default mode of ball shooting mode. Track and shoot the purple ball autonomously. So if I just press the mode button, and it should be the color blue. Right now it's green here. It's green. If I press this mode button, by default it comes with the... Now it's blue. You should be looking for the ball. So let's try to get a good view of this. Here, you've seen the ball. Oh, yeah. You can't really see too well, but yeah, we kind of lost the ball. Oh yeah, I changed the code. So right now he's actually probably not approaching the ball. So I won't show. I'll show that in another Twitch stream. Gonna press mode again. Red mode. What does red mode do? Oh, track black line autonomously. I don't have any kind of black lines. I could get that working eventually. Press mode again. So let's probably SSH in and see what we can do. Go back to green mode, which is just the wireless handle. You run the controller. So it's all built on top of ROS, robot operating system. Squats. Okay. Getting a good view here. Cool. So I showed you, talked about the humanoid type, showed the joints, turned them on, showed the PlayStation controller, show the app as well. Kind of cool that you can see the camera in the screen. So you have to join the Wi-Fi, the access point of the robot, running on the Raspberry Pi. Connected, nice. And now I'm gonna go to the Hiwonder Wonder ROS app, and it kind of looks like this. I'll show better this way, and I'm going to click Ainex. Searching. Cool. I found one Ainex with a specific code, and you do robot control. That's kind of cool. So this is similar to the PlayStation controller, but it's in Android, and you can see what it sees. It sees my OBS Studio. So that's moving to the left straight. That's forward. Kind of cool. Backwards. There's different speeds. I think speed 1 is the fastest. That's kind of not intuitive. Oh no, okay, no, speed. I got a speed 4. Oh, it's like fast speed, but smaller steps. Back. We can change the height that he's squatting. Cool. And then rotation. Hip yaw, that's a lot of hip yaw right there. I see he's gone too fast. I'll go back to speed 2. Come back. And he's also got this get up. Get up. I'm going to put him on the ground. Let's see if he can get up. Nope. That was the wrong. I think that was the forward get up. Try again, but it's a bit dangerous. Give him space. Give him space. Nice. Yeah, maybe I didn't show you the get up button there. Attention. That button does nothing. Okay, actions. There's greet. We've already seen that before. Pretty much I won't use the app because it's all codable. I can build my own app in a web browser. Custom. There's no custom actions. I'd show the football, but maybe I'll do that in another stream because I've changed the code and I'm still debugging and I want him to pick up socks. Instead of shooting a football, so the code probably doesn't work right now, it's running the underlying ROS code. There's line following. I don't have a line to follow, but that's easy to create. I did some line following with wheeled robots, so another time. Target tracking, let's try it out. We could pick purple again, maybe. I'm picking a color. No, not that color. Yeah, this color. Okay, and now start. Ah, that's cool. He's looking at it. Did he lose it? Now it's a different color because of the light. Not that good. That's probably HSV tracking in OpenCV. Let's pick a better spot for the. Like this table's at an angle. Picking this color. I've made this better before, but that's not too good. I've done face tracking pretty well. I can hopefully show that. Maybe he's not seeing it well enough. Okay, so I'm changing this color picking range. I think that's like a better threshold. But now it's seeing me as the object. Okay. Okay. Oh, I put it lower. This is okay. This is good now. That's pretty good. I feel like I can break the motors from being too fast. It's seeing a bit of my t-shirt. Losing his mind. Cool. Okay. You get the idea. Face tracking. Let's see. It says max recognition distance is 1 meter. Well, I'm pretty close. Sees me. And it's waving at me. But it's not doing the face tracking. It's not using the head pan tilt to follow my head. That's still cool. I mean, it's just great. Anyway, that's the default functionality with the app. It's kind of gimmicky. It's good for children and stuff. I want to do more hardcore things, like come to Papa, and pick up socks, and go from there. I want to exhaust him of his capabilities. How many objects can he pick up? We'll see. Back to my stream. So I've shown the app. Finally, I've said multiple times now, it's time to SSH in. I'm going to leave the Wi-Fi of him on my phone. Get this code. I have lots of code here. They haven't shared their repo in open source, but I asked them if I could show it in a video, Hiwonder, and they said it was fine. And I'm kind of making my own private repo out of it, but maybe I should separate my own stuff from their stuff. But anyway, let's join Wi-Fi's. So generally what I do is I join the Hiwonder access point Wi-Fi in one command. First I list all reconnection successful. Yeah, I lost you guys there because so stupid of me. I joined the robot's Wi-Fi. I always forget that. So all I had to do was just join the robot's Wi-Fi, and then in there, then I join my router. It's nice to have him on the access point initially, but then I can always SSH in, join the Wi-Fi of the robot, SSH in, then join my router's Wi-Fi, and now I have normal internet on the robot and on my laptop. So you lost me there for a second. Should be fine. Okay, so let's... Cool. So I'm gonna SSH in. Pi and Raspberry Pi. Cool, so I'm in. Make this bigger. Docker. So there's a Docker container that runs. And here I have a bash run tmux that starts everything I need. The problem is always that code is running on the startup, so I start it again, so it kills everything. Restarting. This is ROS core. Cool. Then I would probably restart it again. We'll make this better in the future. It's nice to have things start on startup, but also then when I SSH in and want to run things in this tmux terminal multiplexer, then I have to restart and kill certain things. Maybe I should just have a kill script for all ROS. Some red writing there. Robot state publisher. I think it's okay. Cool. Does the controller still work? Yeah. Nice. And he greets us again. But now we can see what's actually happening in the code. This format we're seeing here, this is the speed I'm printing. 1000 I think is slower than 200. 200 means go faster in less milliseconds. Do it in less milliseconds. And this format is actually for servo ID 1, go to the pulse angle 500. For servo ID 3, go to the pulse angle 640, which is a certain radian of that servo joint. And as we talked about, there's 24 servos, 24 joints, 24 pulse angles, 24 radians of each of the servos that can be controlled to do anything. You got to be careful. If you set the wrong value, the robot could fall. We don't want that. Cool. So then maybe I can open a new tmux pane here, and I can show some different movements. We've got a motion manager script, and let's run through some of these actions the robot comes with. What else can he show us? So I think it might be best to show on full screen here, and I'll list out. Well, first I'll go to the correct folder. Where was it? Ainex driver, Ainex kinematics, source here. So we can run motion manager is going to run through all these actions you're seeing here. This other functionality we're setting with speed 500, 23, which is the head pan, I think, and head tilt 24, set it to the default kind of like 0 radian position. So now let's run through all these different actions you can do. More than just greet and wave. Let's see what else you can do. I'm running Python motion manager. I hit the bottle. Oh, I'm not really good at that. That's greet and back. It's hurdles. I showed you that before. It does 2 hurdles. And open hurdles. Picking up things. It's like lifting something. Wave. Twist. Raise temp. Raise right hand. That all happened a bit too fast for me to tell you which one was which. Run it again. But I think I'll end the stream soon. So what have I not covered? Showed some code, showed some actions. Another time I should show you the soccer, football, tmux. I've shown tmux. Yeah, let's run through the actions one more time, and then oops, another time. I'll list the actions better this time, or say them better. Okay. That is calib, calibration. Go turn left, go turn left low, greet, hand back, hand open, hurdles. It's an impressive machine. Left hand butt block, place block, put down, wave, that's a cool dance, twist, temp, right hand, raise right hand. Not bad, not too shabby. It's a pretty cool piece of machinery. I actually did some keyframing to make him pick up a sock, so I know that he can pick up a sock. Show my keyframe pick up sock and build new keyframe to pick up sock in front. Now, there's so much technical things to get into there, but like sock picking is hard. They're deformable objects. Like a cube would be easier, very basic object, or even with Ruko markers or April markers like you see over here, you can put this on a cube and make it easier. Just one part. So there's many ways to break down the problem, but one is like visual servoing. Let's see what I'm typing. Many ways to do it. Visual servoing versus full localization of robot plus sock plus gripper. That's complicated. Inverse kinematics, grasping points, everything. And even in visual servoing, it could be like colored cube versus marker cube versus actual sock. Levels of complexity there. So even like for simple robots like this, it's hard. So you could do all of this with motion planning versus like full imitation learning. That's what I'm getting at. Imitation or versus ORL. And this guy can probably do it, but you start becoming more researchy here and needing teams of people. But I have some skills. I've been doing reinforcement learning since 2018, so let's see where we get. But a bit easier is this visual servoing approach. So next time we can talk about that, the IMU, showing soccer and football, and that's what we've covered today. Hopefully it was entertaining. I mean, I think not many people talk about humanoids and have their own humanoid, but they're getting cheaper. And as I said, we need Will Smith to save us, like an iRobot, soon. I don't know how soon. Cool. So thanks for watching. This is more ways for me to be accountable to myself and just kind of build my skills in humanoids. As I said, I've had 162 commits in this repo, so I'm getting better, I'm getting deep, and I'm going to start logging here in this public Notion page. Paste this link somewhere in the switch. We're going to make this guy pick up socks. That's the goal here. Okay. Thank you. Let's stop the stream.